Our IoT platform aims at making drug storage easier and safer. Users can register and add drugs to the service in order to automatically set temperature alarm thresholds based on the fridge contents. The fridge integrates different IoT devices to monitor the temperature and humidity of the fridge and raises different alarms. The service also tracks expiration dates, which will prevent the potentially harmful assumption of spoiled medicines. The whole use case diagram revolves around the catalog manager. It is a REST web service that acts as a provider. It is the registry system of the platform and it manages a JSON file. It provides information about all the devices, users, resources and services in the platform. It also stores configuration settings. Each user must subscribe to the catalog during the startup process via Telegram. Among the other components, there are 3 device connectors for Raspberry Pi, one equipped with a temperature and humidity sensor, the second one equipped with an eye-air motion sensor and a light sensor, and the last one that manages a buzzer. The first 2 are REST Web Service consumers that retrieve information about the fridge status and also work as MQTT publishers. The third one is a REST Web Service consumer that retrieves settings information and also works as an MQTT subscriber to get actuation commands from the other microservices. Then there are some post-process microservices specific to the user. We have a user ID manager to allow user subscription, a temperature and humidity tracker, a fridge opening tracker, an expiration date tracker, and a therapy reminder microservice. Additionally, we have 2 user awareness services, a Telegram bot and Node-RED. All settings information is stored into JSON files. In the catalog file, there is stored information about the MQTT broker and the Telegram token. Additionally, all the data about users subscribed to the service, their drug list and their devices if active. In each device, there are also 3 settings files, one for every device connector, containing the IP of the Catalog Manager REST service. The hardware components used in this project are a DHT11 sensor, a PIR sensor and a buzzer mounted on top of a breadboard and connected to the Raspberry Pi pins. In particular, the temperature and humidity sensor is connected to the GPIO4 pin. The PIR sensor is connected to the GPIO27 pin. And lastly, the buzzer is connected to the GPIO17 pin. The light sensor will be simulated via code. To activate the service, the user must subscribe via Telegram bot. The microservices involved in this process are the Catalog Manager, the Telegram bot, and User ID Manager. When the bot is started, it requests the broker settings information and the Telegram token from the Catalog Manager using 2 GET requests. Then, the user can choose the button New User. The bot then asks for the fridge serial number and it first checks that the given serial number exists in the list containing a JSON file. Then, it compares it to all the serial numbers already taken by other users, performing a GET request to receive all users' data. If no match is found, the user can insert all other personal information to complete the subscription. Now, a new unique user ID is generated by checking that no other user is associated with the chosen ID, performing a GET request to receive all users' data. The bot then performs a POST request to add the new user to the catalog and publishes a message to the broker containing the new ID and the serial number. The User ID Manager microservice then receives the message and updates the settings JSON files needed by the device connectors. The user is now required to do a login to access all the Telegram services, such as using the button User Info to check all their personal information. When the Catalog Manager is running, the function Remove Inactive is called once a day, and devices that haven't been updated for more than 10 minutes will be disconnected. First, the device connector 1 starts running, gets some new measurements and tries to do a put request to update its devices and publishes one message for each sensor containing the measures. If the devices aren't already subscribed to the catalog, the first put request fails and it is redirected as a post which adds the devices to the catalog. updating the user's device list. The T-Tracker microservice receives the messages published by the broker on the temperature/user ID topic, waits to have 5 measures and then computes the average and performs a put request to the catalog to update the device. Similarly, the H-Tracker microservice receives 5 humidity measures at a time, averages them and updates the device by performing a put request. We can also see that the device connector 3, which is required to receive warnings, is currently inactive, because temperature and humidity values are normal. To provide an example, a high temperature has been simulated. In this case, also the Telegram bot microservice is shown. When the user logs in by inserting their ID, the bot does a GET request looking for that user's information. It then performs a put request to update the user's chat ID. Now, the service is up and running. When the T-Tracker microservice averages the 5 measures, it also defines a threshold by choosing the lowest maximum temperature of the user's drugs. Then, the average temperature is compared with the threshold, and if it is too high, a warning message is published on the broker on the topic warning/user ID. The warning message is received by the Telegram bot, which sends a message to the user, and by the device connector 3, which activates the buzzer. When device connector 2 starts running, it subscribes the devices to the catalog through a put request that is redirected as a POS, as seen for device connector 1. It then starts to record the fridge movements and to publish them on the broker. The possible statuses of the fridge are 0 for closed, 1 for open and 2 for still open. This device connector also updates the light sensor, performing a put request to the catalog manager. The opening tracker microservice receives the messages published on the topic movement/user ID and updates the device on the catalog with the new status by performing a put request. When the fridge is in status 1, the device connector 2 waits for some movement. When it is sensed, it checks the light level. If it is high, it means that the fridge is still open, and then the status is set to 2. In the event in which the fridge is left open for more than 2 minutes, the opening tracker microservice publishes a message on the broker on the topic warning/user ID. The warning message is received by the Telegram bot, which sends a message to the user, and by the device connector 3, which activates the buzzer. If the fridge is correctly left closed, the microservice opening tracker periodically updates its status by performing a put request to the catalog manager. When the user logs in the Telegram bot, they can also access all the functionalities shown in the menu, such as temperature and humidity check that shows the user the last measurement done by the sensor by performing a GET request to the catalog manager. Then, the option drug list lets the user visualize all the drugs already added. It also performs a GET request to the catalog manager to retrieve all the drugs associated with the user. In this case, the fridge appears to be empty. The option Add drugs lets the user insert a new drug. The user is asked to insert the name, the maximum temperature, and the expiration date of the new drug. The bot then performs a POS request to add the new drug to the catalog. In case the user wants to add a drug that needs to be stored at a maximum temperature lower than 2 degrees Celsius or higher than 30 degrees Celsius, the procedure is interrupted and the user is sent back to the menu. In case the user inserts a past date, the bot alerts the user that the drug is already expired and terminates the procedure. Now we can see that 2 new drugs have been added to the drugs list. In the option set reminder, the bot first shows the user all their drugs. Then it asks them to insert the ID of the chosen drug to set the reminder for. The user now must select the type of reminder to set, that could be daily, weekly, monthly, or yearly. Then, based on the type of reminder, they must insert different parameters. All reminders need as the first parameter a starting date that must be written in the ISO format and the starting time. If the user makes a mistake, they need to insert a new date or time. For the daily reminder, the only other parameter required is the number of days they want the reminder for. Now, the bot performs a put request to update the drug in the catalog, adding the new reminder. Now, the option drug list also shows the reminder. In the option delete drug, the bot shows again the user their drugs list and then asks them the ID of the drug to delete. Confirmation is required to complete the operation. If the user's answer is yes, the bot performs a delete request. So, the deleted drug disappears from the drug list. With the option logout, the user can pause the service. The last option is delete account. The user is asked by the bot if they're sure, and if they confirm, the account is deleted by a delete request to the catalog manager. Now, if the user tried to log in with the old user ID, it would not be found. The expiration date microservice periodically checks all the drugs added by the user, performing a GET request to the catalog manager. It checks if the current date corresponds to any expiration date or to 10 days prior to any expiration date. This operation is done once a day. If there is a match, a warning message is published to the broker and the user is alerted by a Telegram message. The therapy reminder microservice periodically checks all drugs added by the user, performing a GET request to the catalog manager. Every minute, it checks if the current date, hour, and minute corresponds to any reminder set. If there is a match, a warning message is published to the broker and the user is alerted by a Telegram message. By downloading the Node-RED app on their smartphone, the user can have access to all their fridge information represented in a user-friendly way. From there, they can check the temperature and humidity changes in real time via gauges, which drugs are present in the fridge and their expiration dates. A LED shows whether the fridge is open or not. Temperature, humidity, and the opening status of the fridge are retrieved via MQTT protocol subscribing to the corresponding topics, while the drugs list is retrieved via REST communication by a GET request to the catalog manager. From the menu, the user can also access two graphs showing the trend of humidity and temperature measurements in the last hour. Whenever the temperature and humidity values rise above a chosen threshold, a pop-up notification shows up on the user screen.